Okay, so in this lecture, if you're not too familiar with how encryption works, I want to give you a little bit of details on how it works at a high level. So first, let's talk about encryption in flight, which is going to be referred as TLS or SSL. TLS is the newest version of SSL. So what we have is that the data is going to be encrypted before sending the data, and then it will be decrypted after receiving it. So this is for communication between a client and a server over a network. And so what's going to be happening is that for encrypting the data, TLS certificates are going to be used. And this is what you see when you go onto websites and it says HTTPS. That means that the connection between you and the server is going to be encrypted using TLS certificates. Why do we want encryption in flight? Well, because we're sending data over a network and sometimes a public network, and the data goes around many different servers. We don't want to be having a man in the middle attacks where a middle server receives the data and just observes the packages we're sending to the server. This is why we want to have HTTPS or TLS or SSL. This is when we know that only the target server can decrypt the encrypted data we're sending. So let's take an example. We have a client and a server, and we want to be able to securely log in into the server by providing our username and password. But we only want the target server to be able to receive it. So we're going to have the username and password, and then we're going to apply TLS encryption on the client side automatically. The data is going to be encrypted and sent over the network. So as you can see, no between server can decrypt the data, and only the target server can use the TLS decryption mechanism to decrypt that package and then see that we've sent the username and password and therefore say that we're securely logged in. So that's for encryption in flight. The next one is around server-side encryption at rest. The idea is that the data will be encrypted after being received by the server so that it's stored securely. And the data will be decrypted before being sent back to our clients. It will be stored in an encrypted form thanks to a key, and that key is usually a data key. And so the whole idea of managing these keys for encryption and decryption is that the management must happen somewhere and the server must have access to these keys. So let's take a service, for example, Amazon S3. We're sending an object over HTTP, maybe even HTTPS for in-flight encryption. And so the service receives our object, but it is decrypted. So the service can use a data key, and using the data key and the decrypted object, we can have encryption of that object at rest. And then when it comes to sending back that object to the clients, the encrypted object and the data key will be used together to decrypt. We'll have a decrypted form of object, and then that object will be sent over HTTPS back to the client, so we receive the decrypted object as is. As we can see in this case, there is a server-side encryption because all the encryption and decryption happens on the server. So finally, let's talk about client-side encryption. And the idea is that this time the data is encrypted and decrypted at the client side. And the server should never be able to decrypt the data because we don't trust the server in that case. So for this, we could leverage envelope encryption for this mechanism. So let's have an example. The client has an object and the data key this time is client side. And after encryption, we get an encrypted object. That encrypted object can be sent then securely to any storage service, for example, an FTP server, Amazon S3, EBS volumes, etc. And it will be stored in encrypted form. So the target server cannot even decrypt the data content. When we retrieve the content, we retrieve the encrypted object directly. And if we still have access to the data key client side, then we're able to perform the decryption mechanism and get the decrypted object back. So that's it for the 3 encryption mechanisms we can see in the cloud. I hope you liked it, and I will see you in the next lecture. Okay, so now let's talk about Amazon S3 encryption for your objects. The idea is that you upload objects onto Amazon S3, and these are servers of AWS. And so you may want to make sure that these objects are not accessible. For example, if someone gets into the Amazon servers, or you want to make sure you adhere to some security standards set up by your company. So as such, Amazon gives you 4 methods to encrypt objects in Amazon S3. The first one is called SSE S3. This is to encrypt S3 objects using keys handled and managed by AWS. The second one is SSE KMS, to leverage AWS Key Management Service to manage your encryption keys. The third one is SSEC, when you manage your own encryption keys. And finally, client-side encryption. Now we're going to do a deep dive on all of those, so don't worry. And it's important to understand which ones are adapted to which situation for the exam, because the exam will definitely ask you questions to choose the right level of encryption based on the scenario. So let's do a deep dive first on SSE S3. This is an encryption where the keys used to encrypt the data are handled and managed by Amazon S3. The object is going to be encrypted server-side. SSE means server-side encryption. And the type of encryption is AES 256, which is an algorithm. So for this, to upload an object and set the SSE S3 encryption, you must set a header called XAMZ server-side encryption AES 256. XAMZ stands for X Amazon. So X Amazon server-side encryption AES 256. And this is how you remember the name of the header. So let's have a look. We have an object and it is unencrypted. We have it right now. And we want to upload it into Amazon S3 and perform some SSE S3 encryption. So for this, we're going to upload the object onto Amazon S3. You can use the HTTP protocol or the HTTPS protocol. And you can add the header that we said, the XAMZ server-side encryption AES 256. And then Amazon S3, thanks to this header, knows that it should apply its own S3 managed data key. And using the S3 managed data key and the object, some encryption will happen and the object will be stored encrypted into your Amazon S3 bucket. Very simple. But here in this instance, the data key is entirely owned and managed by Amazon S3. Next, SSE KMS. So we haven't seen what KMS is right now. We'll see this pretty much towards the end of this course on the security side. But KMS is Key Management Service, which is an encryption service for you. So SSE KMS is when you have your encryption keys that are handled and managed by the KMS service. Why would you use KMS over SSE S3? Well, it gives you control over who has access to what keys and also gives you an audit trail. Each object is going to be again encrypted server-side. And for this to work, we must set the header X Amazon server-side encryption to be of value AWS KMS. So the idea is exactly the same because it is server-side encryption. We have the object, we upload it using HTTPS and the header. And then using this header, Amazon S3 knows to apply the KMS customer master key you have defined on top of it. And using this customer master key, so the key you've defined and your object, there's some encryption that will happen and the file will be stored in your S3 bucket under the SSE KMS encryption scheme. Next, we have SSE-C, that stands for server-side encryption, using the keys that you provide yourself outside of AWS. So in this case, Amazon S3 does not store the encryption key you provide, so it will absolutely have to use it because it needs to do encryption, but then that key will be discarded. For this, to transmit the data into AWS, you must use HTTPS because you're going to send a secret to AWS, and so you must have encryption in transit. Encryption key must be provided in the HTTP headers for every HTTP request made because it's going to be discarded every single time. So we have the object and we want to have it encrypted in Amazon S3, but we want to provide ourselves the client-side data key to perform the encryption. So we send both these things over HTTPS, so it's an encrypted connection between you, the client, and Amazon S3, and the data key is in the header. So therefore, Amazon S3 receives the exact same object and the client provided data key. And then again, it is server-side encryption. So Amazon S3 will perform the encryption using these two things and store the encrypted object into your S3 buckets. If you wanted to retrieve that file from Amazon S3 using SSE-C, you would need to provide as well the same client-side data key that was used. So it requires a lot more management on your end because you manage the data keys and Amazon or AWS in general does not know which data keys you have used. So it's a bit more involved. Okay, and then finally, client-side encryption. So it is when the client, so you encrypt the object before uploading it into Amazon S3. Some client libraries can help you do this. For example, the Amazon S3 encryption client is a way to perform that client-side encryption. And as I said, clients must encrypt the data before sending it to S3. And then in case you receive data that is encrypted using client-side encryption, also CSE, then you are solely responsible for decrypting the data yourself as well, so you need to make sure you have the right key available. So as I said, in client-side encryption, the customer manages entirely the keys and the encryption cycle. So let's have an example. Amazon S3 this time is just a bucket where it's not doing any encryption for us because it is client-side encryption, not server-side encryption. And so in the client, we'll use a encryption SDK, for example, the S3 encryption SDK, will provide the object and our client-side data key. The encryption will happen client-side, so the object is going to be fully encrypted on the client side, and then we are going to just upload that already encrypted object into Amazon S3. Okay, so that's the 4 types of encryption, so hopefully that makes sense. And I've been mentioning encryption in transit in this lecture, now I'll make it very clear what it is. That's around SSL and TLS connections. So Amazon S3 is an HTTP service, and it exposes an HTTP endpoint that is not encrypted, and it exposes an HTTPS endpoint, which is encrypted and provides what's called encryption in flight, which relies on SSL and TLS certificates. So you're free to use the endpoints you want, but if you use the console, for example, you would be using HTTPS, and most clients would, by the way, use HTTPS endpoint by default. And so if you're using HTTPS, that means that the data transfer between your client and Amazon S3 is going to be fully encrypted, and that's what's called encryption in transit. And one thing to know is that in case you're using SSEC, so server-side encryption, and the key is provided by your client, then HTTPS is mandatory. Also, so as I said, finally, encryption in flight is also called SSL TLS because it uses SSL and TLS certificates. So let's go into the hands-on to see how encryption works now. Now let's talk about KMS. KMS is going to be everywhere in AWS anytime you hear encryption. So encryption is usually backed by KMS. It's an easy way for you to control who has access to your data, and AWS will manage the encryption keys for us. It will be fully integrated with IAM for authorization and with CloudTrail if you want to track the API calls done to a KMS. So it has seamless integrations with so many AWS technologies. I won't list them all, but for example, for Amazon EBS, it can help to encrypt volumes. For S3, you can do server-side encryption of objects using SSE KMS. For Redshift, you can do encryption of data, RDS as well. SSM, you can encrypt secrets in the parameter store, etc. And on top of it, you can also use the CLI and SDK to leverage the KMS functionality. So overall, it's quite a handy service. It's integrated everywhere. But how does that work really? Well, anytime you need to share sensitive information, you should use KMS. So that includes database passwords, credentials to external services, private key of SSL certificates. And the value that we have when you use KMS is that the CMK, the customer master key, used to actually encrypt and decrypt the data, will never be able to be retrieved by us. And the CMK will be rotated or can be rotated by KMS for extra security. So the idea is that we actually don't manage the keys, AWS manages them for us, and we actually don't perform the encryption ourselves. AWS does the encryption for us, but the idea from it is that we get enhanced security. So overall, why do we use KMS? Well, because we should never ever store your secrets in a plain text file, especially in your code. So when you have an encrypted secret, you can store it in your code. This time this is fine, or maybe in an environment variable, even better. So KMS, when is it helpful? Well, it's helpful when you want to use encryption of up to 4 kilobytes of data per call. So you cannot pass a huge file to KMS and tell it to encrypt it. So if your data is greater than 4 kilobytes, which can happen for very, very big data sets in big data, you should use envelope encryption. And that gives you basically a functionality that I won't go in depth here, but basically will generate a new data key, and that data key will be used to encrypt the big data sets. So overall, think KMS, straight KMS for 4 kilobytes of data, and envelope encryption if your data is greater than 4 kilobytes, but envelope encryption anyway leverages KMS. Okay, so to give KMS access to someone, you basically need to set a key policy to allow the user, and you also need to make sure that the IAM policy allows the API calls. All right, so let's have a look at how it works on the KMS side. So you are able to fully manage the keys and the policies. So you can create keys, do key rotation policy. You can even disable keys or enable a key back. You can also audit the usage of the keys, for example, using CloudTrail. And you have three types of CMK you can define. You can have AWS Managed Service Default CMK, which is what you get for free for every service, for EBS, S3, all these things. Any service will have AWS Managed Service Default Key. You can also create your own keys for $1 per month, or you can import your own keys. You basically create them on your own, and then you import them into KMS, and that's $1 per month as well. And then you're going to pay for each API call done to KMS, so 3 cents per 10,000 API calls. What does that mean? That means that anytime you encrypt and decrypt data, you're going to be charged a very, very small fee. But you need to be aware of it because it's really important, because if you have a big data set, say of 1 million files, well, you can make the math, but it will cost you about $3 to decrypt everything or to encrypt everything. Okay, so how does KMS work from a diagram perspective? Well, say you have the client or SDK and you have a secret, for example, it's a password, and that password is not very long, so it's less than 4 kilobytes. Well, you have the KMS service, and you're going to use the encrypt API. What will happen when you use the encrypt API is that within the KMS service, it's going to look at the CMK you want to use and say, okay, is the user allowed to do this CMK encrypt call directly within IAM? So you look at IAM, okay, you have the IAM permissions, it will look at the key policy and say, okay, you do have access to both these things, so I'm going to perform the encryption. So the encryption happens, and then KMS will send you back the encrypted secret. So on our end, we have never seen the CMK, we just sent something and we received back an encrypted secret. So we're going to store that encrypted secret, and later on, our application needs to decrypt that secret. So we're going to use the CLI or the SDK again, issue a decrypt API call, and using the same CMK, again, KMS will check the IAM permissions, making sure we do have the decrypt access, and also look at the key policy. And then the decryption will happen, and it will send us back the decrypted secret in plain text. So this is how it works. This is basically how KMS, works from a diagram perspective. What I want you to remember out of it is that we never ever get to perform the decryption ourselves. KMS does it for us using the CMK that it has access to, but we do not have direct access to the CMK. You also need to make sure that, realize that it is tightly integrated with IAM permissions to ensure that everything is secure along the way. Now, how does encryption work in AWS services? Well, some require migrations. For example, if you create a snapshot or a backup, so if you have an EBS volume and it's unencrypted and you want to encrypt it, you first need to back it up or to make a snapshot and then create an encrypted volume. Same for RDS, Elasticache, or EFS. But one technology does allow you to just encrypt something in place, and that's S3. So if you wanted to have an unencrypted file and encrypt it right away, you could use KMS for that. Just enable encryption, and KMS encryption will happen on the fly, and that's something that's good to know. But that's the only technology in AWS that does allow this. All right, so that's all for KMS. I really hope that was helpful, and I will see you in the next lecture. So let's talk about an important advanced topic for KMS, which is key rotation. So you can enable automatic key rotation for a customer managed CMK, so not an AWS managed CMK. And if you enable the automatic key rotation, it will happen every 1 year. And after 1 year, the key will change, but the previous key will be kept active so that obviously you can be able to decrypt your old data. The new key will have the same CMK ID though, so that means that only the backing key, the backing material of that key will be changed. So let's take an example. Here's the backing key, and here's the CMK ID. And so after automatic rotation, which happens every 1 year, and you cannot change the period, it has to be every 1 year, then the backing key is going to change. So that means the material of the key is going to change, but the CMK ID remains the same, and the old backing key is going to be saved so that you can still decrypt the old data. That's for automated key rotation. But you can also rotate your key manually. For example, you want to rotate your key every 90 days or every 180 days, these kind of things. The new key will have a different CMK ID because you create it manually. So the idea is that you will keep the previous key active, obviously, so that you can decrypt all data. Otherwise, you will lose access to all your other old data. And in this case, it is better to use aliases when you encrypt and decrypt data. Because if you use aliases, then you hide the change of key for the application. And I will show you this in diagrams. So it's a good solution to rotate a CMK that is not eligible for automatic rotation as well, such as your asymmetric CMK. So here's an example. The client is currently talking to alias my custom key, and we have a backing key and we have a CMK ID. and then we're going to rotate the key manually by creating a new key, and we're going to change the alias. And so what happens is that there's going to be a new CMK ID. Your old backing key is still going to be around here, okay? But now your client, thanks to the new alias, is going to point to the new material, and you have done a manual key rotation. So how does it work to update the alias? Well, you update the alias to hide again the change to your application. So your application only interacts from an API perspective with your key alias, my app key. And then the old key of the key alias is the one you had before rotation. And after rotation, you're going to create a new key, and you're going to issue an update alias API call. And this update alias will have the alias point to the new key. And therefore, from an application perspective, the change will not be detected. It will just be transparent, okay? So what you need to remember from an exam perspective is that if you want to have automatic key rotation, the period is 1 year. But if you want to have manual key rotation, then you can go to 90 days or 180 days based on the requirements. And all the extra information I gave you is just to show you how this would work in real life, but the exam will not test you on the details as far as I know, okay? So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. Let's talk about another way to perform encryption on your cloud, and that is going to be different than KMS. This one is called Cloud HSM. So with KMS, AWS is the one that manages the software for the encryption, but with Cloud HSM, AWS will just provision you the encryption hardware, and you have to use your own client to perform the encryption. So HSM is a dedicated hardware to you. HSM actually means Hardware Security Module. The idea is that you give you a hardware, a physical thing within Amazon, and you manage all the rest. So you manage your own encryption keys entirely, not AWS, and AWS does not have access to your key or cannot even recover them. The HSM device is tamper resistant, so no one from the AWS team can touch your device, and it has very high level of compliance. The HSM clusters can be spread across multiple availability zones, so it's highly available, but you must set this up as well. It supports both symmetric and asymmetric encryption, which can be really helpful if you want to generate some SSL or TLS key. There's no free tier available, and to use Cloud HSM, you must use your own Cloud HSM client software. So example of services that do integrate with Cloud HSM, for example, Redshift, has support for Cloud HSM for database encryption and key management. Or Cloud HSM is also a really good idea if you choose to use SSEC as an encryption mechanism for S3. And then in this case, the key management software will be within your HSM. So just to get an idea of like HSM, this is the diagram. So as you can see here, AWS only manages the hardware, and if AWS cannot recover your keys if you lose your credentials. So really, if you decide to go with HSM, you need to make sure that you manage your keys and have a very strong way in place to not lose that keys. And then your Cloud HSM client will have a connection to your HSM device to get, write, and generate some keys. So what is the IAM permissions then? How are they helpful? Well, for IAM, you can create, read, update, and delete an HSM cluster, but you cannot manage the keys within. To manage the keys within, you need to use the Cloud HSM software that is not within the console, and that allows you to manage the key and manage the users. But that is not regulated by IAM. This is really up to you to set up your own security within your Cloud HSM. So I hope that helps, and I will see you in the next lecture. So let's do a review of security in all the AWS services that we've seen so far. This is going to be long and boring, but trust me, pretty much needed for the exam, so let's get started. First, Kinesis is comprised of Kinesis data streams, and Kinesis data streams has SSL endpoints, so we can use the HTTPS protocol and do encryption in flight. That means sending the data to Kinesis securely. There's also KMS integration to provide server-side encryption, and that gives us encryption at rest. And on top of it, we can do client-side encryption, but we must use our own encryption libraries. There's no support for it in the Kinesis service, and we would need to use the KPL, the producer library, to do so, but we would need to also provide the encryption on our own. There is a supported interface for VPC endpoints, private link. That means that we can access the Kinesis service within our private EC2 instances privately. We can use KCL to read from Kinesis, but remember, if you do use KCL to read from Kinesis streams, then you must also grant read and write access to a DynamoDB table. Why? Because that KCL will use that DynamoDB table to do checkpointing and sharing the work between different KCL instances. So remember that. Now for Kinesis Data Firehose, well, we attach IAM roles. So we can deliver data to S3, Elasticsearch, Redshift, and Splunk. Hopefully you remember these 4 destinations. And on top of it, the entire delivery stream can be encrypted using KMS, that is server-side encryption. There's also support for VPC endpoints and private links to access privately. Finally, for Kinesis data analytics, we can attach an IAM role to it so you can read from the Kinesis data streams we need and reference the sources, maybe for reference data, and write an output to an output destination. For example, that output destination may be either a Kinesis streams or a Kinesis firehose. So that's it for all the security on Kinesis. Let's get to the next technology. The next technology is SQS. SQS will give us encryption in flight using the HTTPS endpoint, so we can transfer data to SQS securely. We will also have server-side encryption using KMS, and you must set an IAM policy to allow the usage of SQS. There's also a second level of security we can set using SQS queue access policies and ensuring that our users do have access to the SQS service. This is very similar to, say, an S3 bucket policy. If you want to do client-side encryption, as usual, you must do it manually and you must do it yourself. This is not something that's supported directly by the service. And you get a VPC endpoint that is provided through an interface if you wanted to access the SQS service securely. All right, next. Next is AWS IoT. IoT has many different securities, I don't know if you remember, but the first one is policies. Basically, we are going to create X509 certificates or cognito identities into our devices, and using the IoT policies, we can control everything. We're able to revoke any device at any time, and the IoT policies are JSON documents, just like IAM policies. They can be attached to groups instead of individual things, so we can basically group the things together and just manage groups policies instead of things policies. So that was for things security, but then we can get IAM policies to look at the access of the users, groups, or roles within the IoT service. So it can be IAM policies attached to user, group, and roles, as I said, and then you can basically use that to control access to the IoT APIs at a high level. For example, creating a rule or creating a rule action, that kind of stuff. And then you attach roles to the rules engine so that they can perform their actions. So if your rules engine action is sending data to Kinesis, you need to attach an IAM role to that rule, basically so it can perform its action and send data actually to Kinesis. Okay. Now S3, we've seen this so many times, the security of S3, but one more time. We get IAM policies, S3 bucket policies, access control list, encryption in flight using HTTPS, encryption at rest of many different kinds. We get server-side encryption, SSE-S3, SSE-KMS, SSE-C. We get client-side encryption, such as Amazon S3 encryption clients. And then we get versioning and MFA delete, basically to make sure the data doesn't get deleted by mistake. We can get cores for protecting websites and making sure only a few websites get access to our S3 bucket. We get VPC endpoint that is provided through a gateway endpoint, basically to access S3 securely from my private subnet. And we have Glacier. I just included Glacier in there. That has a bunch of stuff, but including these things called vault lock policies that are very helpful if you want to prevent deletes, for example, for regulatory reasons. And that's called also a warm policy, write once, read many. Now let's talk about the security for DynamoDB. So the data is going to be encrypted in transit using TLS or HTTPS. And then all your DynamoDB tables are going to be encrypted at rest. It will be using KMS encryption for base tables and secondary indexes. And you have 3 options. The first one is to use the default AWS owned key, which is free of charge. The second option is to use an AWS managed key, which is, for example, AWS/DynamoDB, which is going to incur some KMS charges. Or the last one is to have an AWS customer managed key, your own, okay? And you are also going to have KMS charges for it. Now, all the access to DynamoDB tables, to the API, to DynamoDB DAX cluster are always going to be authenticated and authorized using IAM policies. Now, if you do enable DynamoDB streams, they are also going to be encrypted with the same encryption mechanism as your DynamoDB table. And if you wanted to access your DynamoDB table privately, you could use a VPC endpoint, which is going to be provided through a gateway. So that's it for this lecture. I hope you liked it, and I will see you in the second part for more security on other services. Next up is RDS. So what do you get through RDS? Well, RDS databases are deployed within your VPC, so that will provide you with network isolation. Then you can use security groups attached to your RDS instances, and that will control the access to database instances on specific ports from specific IPs ranges, such as CIDR, or other security groups. Also, you can use KMS to provide encryption at rest of the data in RDS, and you can use SSL for your JDBC connection to provide encryption in flight when you talk to your RDS database. IAM policies do not provide protection from within the database, they provide protection to the RDS API itself. And IAM authentication is a means of authentication that's supported by only two technologies, PostgreSQL and MySQL. So you must manage user permissions within the database itself, so that doesn't make it as good as DynamoDB in terms of integration with IAM. So once your users are created, either using IAM authentication or just manual users through the Postgres and MySQL API, then within your database, you're supposed to say, this user has access to this table. But this is not something you manage through IAM, this is something that's managed from within the database technology. There's also this little known fact that Microsoft SQL Server and Oracle support something called TDE, called Transparent Data Encryption, and it can be enabled on top of KMS and to provide more encryption on your data, even more. All right, so that's it for RDS. Hope that makes sense for you. Hope that's not anything new. For Aurora, well, it's actually very similar to RDS. We get VPC to get network isolation, security groups to control who has access to our database, KMS to get encryption at rest, SSL to get encryption in flight, IAM authentication for Postgres and MySQL, and we must manage the user permissions within the database itself. Remember, Aurora does not support anything such as Oracle or Microsoft SQL Server. Right now, it's only Postgres and MySQL in terms of compatible APIs. All right, leaving the database well, let's go into Lambda. So Lambda, how does that work? There's a lot of security around it. First of all, your Lambda function must have an IAM role attached to it. So each Lambda function will have its own IAM role, which will define the permissions of what it's able to do. Well, why do you need permissions? Well, because Lambda will pull data from sources and will send data to targets. So basically, the IAM roles attached to your Lambda functions will help you decide what your Lambda function can do in terms of sources and targets. Lambda has integration with KMS for encryption for secrets. So for example, if you want to pass a secret to your Lambda function, you could use KMS encrypted variables and run the decrypt function within your AWS Lambda function, provided it has the right IAM roles. You could also use the SSM parameter store to store configurations in your AWS Lambda function and even encrypt the secrets within SSM with KMS. It has integration with CloudWatch logs. Again, make sure that the IAM role is correct. And you can deploy your AWS Lambda functions within your VPC in case you need to access resources from within your VPC. So we saw before that RDS is deployed within your VPC. If you need a Lambda function to basically interact with your RDS database, you would deploy your Lambda function directly into your VPC privately. All right. Now we have Glue. So to control access to the Glue service, you can use IAM policies for that. So this is like any other AWS service. And you can also configure Glue to access your databases with JDBC only by using SSL. So that means that you want the encryption to be enabled while the connection from Glue to your database is being made. Okay, so that means that your data in flight is being encrypted. The data catalog, very important to understand this and remember it from the security standpoint. First of all, you can encrypt the data catalog by KMS. So that means you make sure that your data is encrypted at rest, but also you can create resource policies that can protect the data catalog resources. So this is very similar to an S3 bucket policy. So when we have an S3 bucket policy, our S3 bucket is protected against unwanted access, and we can define that in the bucket policy. We have the same concept with the data catalog resources. We can create resource policies to protect these resources, and that's something to remember going into the exam. The connection password can be encrypted by KMS for enhanced security. And finally, any data written by Glue can also be encrypted. So we have a security configuration for the S3 encryption mode. So we can have server-side encryption S3 or server-side encryption KMS. We can enable any CloudWatch encryption for the logs. And finally, the job bookmarks can be encrypted as well. So remember, going into Glue, a lot of things can be encrypted and the data catalog can be protected using a resource policy. And finally, Glue can be configured to access your databases only through SSL to maintain encryption in flight. So that's it for this part 2 of the AWS Services Security. I will see you in the next lecture for part 3. Okay, so we are in part 3 of our security analysis of the services. and we are starting with EMR. Now, EMR is something that's going to be extremely important to understand the security of going into the exam, and so as such, you need to pay a lot of attention into the next 2 slides, and you need to remember everything I'm going to say. So let's get going. So first, because EMR provisions some EC2 instances, it is possible for us to provision a key pair to manage SSH access into these instances. We can also attach IAM roles to these EC2 instances. Why? Well, because maybe you want to access S3 using EMRFS for doing the request, or maybe you want to write data back into S3 for whatever reason. So you need to make sure that the IAM roles have access to S3, obviously. If you are accessing the DynamoDB and you need to use Hive for this, then you need to make sure again that your EC2 instances are permissioned to access DynamoDB. And again, this IAM role is crucial to achieve just that. Now, for security groups, you have 2 kinds. You have the first kind, which is for the master node, and the second kind for the cluster nodes, which represents the core node and the task node. And the reason why we have security groups is to allow node-to-node communication, because say you are running a Spark job or a distributed MapReduce job or anything that does require your nodes to talk to one another, then you need to make sure that the network security rules are in place to allow these communications. So security groups are extremely important. In terms of authentication, we have Kerberos authentication, and this is helpful when you want to connect your authentication mechanism to Active Directory. And then finally, there is an open source way of managing security on EMR for authorization, which is called Apache Ranger. So it's RBAC, role-based access, and you need to set this up on an external EC2 instance and then connect it to your EMR cluster. So that's not something you can set up directly from EMR. You have to set up externally on EC2 and connect it, set it up with your EMR cluster. I would recommend reading that blog if you want to know more about this EMR security. I think it's a very interesting blog to read and something that could be very useful going into your exam. Okay, the next for EMR is going to be around EMR encryption, and that's super important to remember everything I'm going to say. So we have at-rest data encryption for EMRFS. So EMRFS is when your data lives on Amazon S3. As such, we need to encrypt the data in Amazon S3. So we have 3 different options. We have SSE S3, SSE KMS, or even client-side encryption. So 3 kinds. As you can see, the 4th kind, SSE-C, is not supported by EMRFS. You can also encrypt the data in your local disks. So using this EMRFS, you have both the encryption happening on Amazon S3 and on your local disk. Let's talk about these local disks in further. So you have different kind of encryption for your local disk. The first one is open source HDFS encryption, which is to rely on whatever encryption has been created for the Hadoop ecosystem and use that in your Hadoop cluster. But you can also use some more AWS native encryption mechanisms. So if you have an EC2 instance store, so that means that your storage is attached physically to your EC2 instance, then you can use NVMe encryption or LUKS encryption. Okay, remember these 2 things. And next, if you have an EBS volume, so that means that your storage is not physically attached to your EC2 instance, I mean it's attached through the network, then you can have EBS encryption, the native encryption using KMS. And the good thing about it is that it works for the root volume of your EC2 instance, very important to remember. But you can also use LUKS encryption, and in that case, it does not work with roots. So if you come to an EMR cluster that is backed by EBS and you want to make sure the EBS volume are encrypted, including the root volume, then you have to go with EBS encryption KMS, not LUKS encryption. Okay, that's for at rest. Now for in transit, we can have encryption between your nodes so that there's node-to-node communication that's being encrypted using SSL. And you can also make sure that any traffic done from EMRFS, so between S3 and your cluster nodes, is also going to be end-to-end encrypted using TLS. This diagram can be helpful to remember things and put it into perspective, and this comes straight out of the documentation of EMR for the data encryption options. So as I said, you have to remember everything I just said for EMR. These will be some very valuable points going into the exam, so hopefully that's helpful. The next technology is going to be Elasticsearch. And so we can deploy it within our VPC, and that will provide us with network isolation. And we can also set Elasticsearch policies to manage security further, for example, to restrict by IP address or whatever. In terms of data security, we can encrypt the data at rest using KMS, and we get encryption in transit using the HTTPS endpoint through SSL. For how do we manage the Elasticsearch service? Well, we can get IAM or Cognito-based authentication. And if we use Cognito, well, that allows the end users, for example, to log into Kibana directly through enterprise identity providers such as Microsoft Active Directory using SAML. So a lot of keywords I know, but at least you need to understand how one can log it into Kibana, maybe using Cognito. Okay, so now we have Redshift, and Redshift is also very, very, very important to know in terms of security. So the VPC will provide you with network isolation for Redshift, and you can on top of it apply cluster security groups to ensure you do have control over which machines can access your Redshift cluster. You get encryption in flight because you're using the JDBC driver enabled with SSL, so you can definitely encrypt your data directly going into Redshift. And you can encrypt at rest using KMS or an HSM device. And so if you use an HSM device to encrypt at rest in Redshift, you need to establish a connection between your HSM device and Redshift. All of that is well documented on the AWS documentation. What you need to remember is that Redshift is that one technology that can use either KMS, and this way it's managed by AWS, or we can use a custom HSM device or hardware security module. It also supports SSE/S3 using default managed keys, and you can attach IAM roles for Redshift, basically allowing you to dump or read data from S3. So, okay. Finally, if you use a copy or an unload command, you can reference the IAM roles that you have assigned to Redshift, or alternatively, if you wanted to inherit your own key credentials, you can paste your own access key and secret key directly into your SQL statements, and Redshift will leverage those when reading data from S3 or writing data to S3. Okay, hope that makes sense. Again, make sure that you really know Redshift security very well. Athena is very easy. You use IAM policies to control access to the Athena service itself. And the data will be stored in S3 anyway, so you inherit all the security that comes from S3. That includes IAM policies, bucket policies, and ACLs. You're going to encrypt data according to S3 standards. So we have SSE/S3, SSE KMS, and CSE means client-side encryption for KMS. You can get in-transit encryption, obviously, because using TLS certificates between Athena and S3, and you can use a JDBC driver that's going to be enabled by SSL. Finally, if you need fine-grained access, you can use the AWS Glue Catalog security itself to restrict who can do what in Athena. All right, that's it for the query technologies. Finally, the visualization technology of QuickSight. Well, you have two kind of editions. You have the standard edition, where you can use IAM users to log into QuickSight or email-based accounts. And for the enterprise edition, you can use Active Directory-based security to log into QuickSight. With a federated login, it also supports MFA or multi-factor authentication. You get encryption at rest and in Spice as well. So you get encryption at rest within QuickSight and within the processor engine. And finally, if you wanted to get row level security to control which user can see rows, that is now a new feature from QuickSight, which I believe is supported by both editions. So that's it for all the technologies overviews and security. Could be boring, could be a lot of information, but you do need to know all this information going into the exam. So here it is to you. Feel free to take your time, revisit them one by one, read some blogs, and get familiar with them. All right, I hope you like this, and I will see you in the next lecture. Now let's talk about STS. You may already be familiar with it, but let's just go over it one more time. STS stands for Security Token Service. It basically allows to grant limited and temporary access to AWS resources. Basically, with STS, we'll generate tokens, and these tokens will be valid for up to 1 hour. They must be refreshed, and they will allow to access some AWS services. Where will we use this? Well, we'll use this mostly for cross-account access. So we basically allow users from one AWS account to access resources in another account. We also use this for federation, and we'll see federation in detail in the next lecture. But for example, for Active Directory, we'll provide a non-AWS user with temporary AWS access by linking Active Directory credentials, or we can use SAML to basically do the same, or we can use single sign-on to basically allow users to log into AWS console without assigning IAM credentials directly. So STS is used by many other things. Anytime you have a security code token that's temporary, STS is in the play. We can also use STS for federation with third-party providers, such as Cognito, and we'll see all this federation stuff in the next lecture, don't worry. And it's used mainly for web and mobile application when you have Cognito in play. And it makes basically the use of Facebook, Google, Amazon login to federate all these logins together. So STS, just remember, overall, it allows you to get temporary access to AWS resources, and it's used for cross-account access. For the federation stuff, next lecture. Now for cross-account access, how does it work? We'll define an IAM role for another account to access, and we define which accounts can access this IAM role, and then we'll use STS to retrieve credentials, okay? And then with these credentials, we'll be able to impersonate that IAM role, and that's called Assume Role API. Then the credentials can be valid for between 15 minutes to 1 hour. So as a diagram, how does it look like? We're a user, and we want to access a role, either in the same account or in another account. So we want to access it. How do we do this? Well, we'll do the Assume Role API on STS. STS will check the IAM permissions, making sure you can do it, and then it will send you back temporary security credentials, and these security credentials will basically allow you to impersonate that role that you wanted to assume. So that's it. That's all you need to remember. It's quite easy when you think about it, but it's good to see it once. Again, STS is a service to give you temporary security credentials based on what you can access. So in the next lecture, we'll see federation, and that will be very interesting. Okay, so let's talk about identity federation. You may have heard identity federation many times in AWS, and to be honest, for me, it was quite a cryptic topic. It's really hard to understand. So I'm doing my best here to explain to you how identity federation works, what the SAML and Cognito, how it is integrated with all these things. So let's take it step by step, and hopefully you'll have a clearer view of it after this lecture. So federation means that we'll let users that are outside of AWS to assume temporary roles to access our AWS resources. What does that mean? That means that our users don't need to have a user in AWS to access AWS. How does this dark magic work? Well, basically the users will assume an identity provided access role. So that's a lot of information already. Let's go through a diagram to understand better how this works. So we are a user, and we're in our company, or we are a mobile app user, whatever it is. We're a user and we don't have an account in AWS. But what we do have is access to third-party servers for login. It could be our companies, it could be whatever. And this third party is trusted by AWS. So we have defined beforehand a trust between that third party and AWS. What happens is that our users will connect to this third party, and through some complicated process that we'll see in a second, the third party will give back credentials. They will be temporary to our to our user, to us. Then as a user, what can we do with these credentials? When we can directly access AWS through the console or the API. So this is how federation works, identity federation. That's because the identity is stored somewhere else, or stored on a third party. If you understand this, you've basically understood identity federation. Now, identity federation, what is this third-party authentication that we're talking about? It could be LDAP, it could be Microsoft Active Directory, which is also assimilated to being SAML. SAML is a standard, but Active Directory is an implementation of it. It could be single sign-on, it could be OpenID, it could be Cognito. So all these things can be third-party authentication. And so using federation, the thing you have to remember is that we don't need to create individual IAM users. The user management is done outside of AWS. So for the exam, they may ask you about some very specific form of identity federation, namely SAML, custom broker, and Cognito. So we're going to see these three in details right now. The first one is SAML federation, and that's for enterprises. Basically, if you're a large enterprise, you most likely have a Microsoft Active Directory, or you have something SAML 2.0 compliance where you already manage your users through this, and you basically want to integrate this with AWS. What this gives you is that now all your users automatically have access to the AWS console or the CLI through the temporary credentials. So you don't need to create a new IAM users for each of your employees, which is quite nice. So how does it look like? This is a diagram. Now this may be a very complicated diagram. It comes straight from the AWS documentation, but it is very clear. So let's walk through it one step at a time to understand what happens. We are the client app, and we are within our organization, so a large organization. What we'll do is that we'll go to the identity provider, IDP, which is SAML compliant, so it could be Microsoft Active Directory, and it will authenticate the user based on the user database. Then when we're authenticated to this IDP, the IDP will send back a SAML assertion. It's basically a token. A SAML assertion is basically a token. Now we get some SAML assertion, and what we'll do is that automatically we'll call assume a role with SAML to STS, which is a special API on STS, and STS recognizes this SAML assertion and will give us back, we'll trade this SAML assertion for temporary security credentials. So now we've basically logged in, got a SAML assertion, traded that SAML assertion from STS to security credentials. And now with the security credentials, we can, for example, access AWS just normally, for example, an S3 bucket. That's if you want to have a CLI-based access. If you want to have a console-based access, there's also a nice diagram by AWS. The idea is the exact same. From our browser, we'll access the portal of an identity provider, so it's like a web-based thing. We'll get authenticated, same thing. Then the IDP will return a SAML assertion. And now we can use that SAML assertion directly to sign in into the AWS SSO endpoint, which behind the scenes talks to STS. And then once it's all validated, once your SAML is traded for STS, then we'll validate the whole thing and you get redirected to the AWS Management Console right here. So the idea is the same, right? If you look again, we trade our identity internally for some AWS credentials. And basically there is just a bunch of back and forth that happens. So if you understood this, then you understood SAML federation. It's actually not that complicated. Now, if you don't have a SAML 2.0 way of identifying your users, then you need to use custom identity broker. So that's only if you don't have a SAML 2.0, and that's a bit more complicated. Basically, you have to program what's called an identity broker, and it's an application, and you have to program it. And this identity broker must be used to determine the appropriate IAM policy you apply. So what's the change? Well, here it is. Again, we have our users, browser, or application. We'll access our identity broker, and the identity broker is something that we have to program. Okay, this whole thing in the green dot, green circle is something that we have to program. And the identity broker will validate our identity with maybe a corporate identity store, authenticate it, and then if it's happy, it has superpowers, it has super user superpowers, and it can ask from STS any security credentials for any policy. So it's up to the identity broker to really tailor a policy just for the user that was connected. So it's a bit more work to do, and that's why it's called custom identity broker application. So we have to create this. It goes to STS, makes a request for security credentials. The security credentials come back, they're given to our users, and then they can either access AWS with the APIs or get redirected to the AWS Management Console, and we can access AWS. So it is the exact same principles as SAML, but it's not SAML, and therefore we have to do a lot more manual work. We have to do a lot more work to implement that identity broker. So if you see custom identity broker, that means enterprises, but not SAML 2.0. Whereas before, if you see SAML 2.0, that means identity federation directly integrated with AWS. And finally, this was for our corporate users. So anytime you are basically sitting at a desk at your corporation. But what if you have an app? And an app, your users need to basically put files into an S3 bucket. How do we do this? Do we create a user per app? No, that doesn't sound scalable, right? So the goal is to provide AWS resources access directly to our users of our app. How do we do this? Well, we log in through a federated identity provider, or we can remain anonymous. Then we get AWS credentials back from what's called a federated identity pool, and that comes straight from Cognito. And then these credentials will come with predefined IAM policy that basically allow users to do what they need to do. Don't worry, there's a graph. So an example of it is, anytime you want to provide temporary access to write to S3 buckets, maybe using a Facebook login, you should use AWS Cognito and federated identity pools. Note, there is something in the documentation called Web Identity Federation. You may have heard of it before, and it is an alternative to Cognito, but now in the documentation, AWS recommends against it, and it says you should just use Cognito because it does the exact same thing. So for this reason, I'm not teaching Web Identity Federation because it's not at the exam anymore. Cognito is going to be the way to have public applications access AWS resources. Now, concretely, how does that work? We have our app, and our app is directly connected to our identity provider. It could be Cognito User Pool, Google, Facebook, Twitter, SAML, OpenID, whatever you want, right? But it's an app. It's out on the wild, it's public. So our app logs in to our identity provider and gets a token back from it. Then the app will talk to the federated identity provider in Cognito and will basically trade in that token that will be verified by the identity provider. And then the identity provider will get credentials from STS. And then same pattern as before, the federated identity on Cognito will send us back temporary AWS credentials. And now using these credentials, we can directly talk to our S3 bucket and make some calls and see if we're authorized to do what we need to do. So that's the idea. Here, the difference is that now we connect to public identity providers such as Cognito User Pool, Google, and Facebook. But the idea is exactly the same. We trade in a token we retrieve from a third party to a service on AWS to get back some temporary AWS credentials. So if you understood this, you understood federation, take your time, review the graphs, look at the documentation, review this lecture. I promise it will make sense after a little bit. Just write it down on a piece of paper. It's quite hard sometimes to understand how these things are orchestrated. It takes a lot of time for me to get to understand this. But once you understand it, it makes total sense. And any question at the exam that talks about federation, you will not be afraid of it. You will be embracing it and happy that you know the answer right away. So I hope you enjoyed this lecture. I will see you in the next one. So this lecture is a little bit special, but I want to introduce you to reading advanced IAM policies and understanding what they mean, because it's possible you will see some advanced policies at the exam. So we'll use these several links. We'll start by this one, but in there, I first want to introduce your attention to using the $AWS username. This basically will get the value of your username in AWS, and the use case for it is that you can restrict maybe users to several DynamoDB tables or keys, or maybe several buckets, subfolders, or keys as well, prefixes using that variable. You can also use the AWS principal type as an IAM variable. So for example, a policy variable, for example, is it an account, is it a user, is it federated, or is it an assumed role? So you can really have very tailored policies. You can also use tags. For example, is the principal tag equals department? If so, yes. If not, no. So you can really have some really advanced concepts thanks to all these variables to restrict your IAM policy. So let's have a look at this link. Maybe it'll make things a bit clearer. So I'm just here to introduce you to this link. You can read it in your own time, but basically it's saying, okay, if we have an S3 bucket and we want to allow people like David to use the David prefix in our S3 bucket, we would need to create that fixed policy and assign it to the user David. But if we have another user, for example, Mike or whatever, then we need to create another policy for Mike, and that becomes really cumbersome when you have hundreds of users, right? So instead you can use policy variables, and you would replace this with maybe a group, and within that group you would assign the group policy, and you would assign this. So instead now the S3 prefix is not David anymore, it's $brackets AWS username, close a bracket. So this will basically get replaced at runtime by the dynamic value of the user using your policy. And so that's a really cool thing here, is that now you can have very applicable broad policy to everyone using variables. So it basically introduces you to using the curly braces, the $, and reading this. And so if you scroll down in this page, basically you can see a lot of things that are possible to do. So it shows you how you can use S3 buckets, for example, or we can define a queue per user, for example. So if you want to have the users to be able to list the queues but only operate on their own queues, you would define this in the resource name, etc., etc. You can also use, for example, resources for buckets to have certain certain tags within the buckets to only allow tags that are tagged with the bucket department. Who knows? So you can really become very creative with your policies, and this is what I want to teach you here. So you can definitely just read more through the document, but here is a table or a list of all the stuff you can use. So current time, epoch time, principal type, secure transport, source IP, user agent, user ID, username, source instance ARN, and on top of it, it gives you the different values for these variables based on the type of principal you get. So it really educates you. The reason I'm showing you this is not for you to learn all these things by heart, but it's that if you encounter a IAM policy that looks a bit like this one, you need to be able to say, okay, this is a variable, Stefan explained this to me, so that means that this will get replaced at runtime by the username of the account. And so the user only has access to a specific queue. Okay, let's move on to the next section. So these things work great when we're within AWS, but what about federated users? For this, there's another link, obviously. And so we'll get another variable called AWS federated provider, which basically will be replaced by the identity provider that was used for the user. So it could be Cognito or Amazon.com or whatever. And then within each IDP, we will have specific variables to access the username. For example, if it's Amazon.com as an identity provider we use, then the variable to access the user ID will be $www.amazon.com : user_ID. And if we use Cognito, it'll be something else. It'll be cognitoidentity.amazonaws.com:sub. So you basically get the idea that based on the identity provider, it could be also SAML or STS. Basically, each of these will expose its own variable. So again, not something you need to know by heart, but something you need to see once so that if you do see it in the exam, then you're aware of it. So now if we explore the second link, you will see some example policies using Web Identity Federation. And so here in this S3 policy, we can do a get object from anyone as long as the resource name is the bucket name with the federated provider. So basically saying, okay, we have a specific bucket for each federation provider. So we can get different providers, we can get Cognito, we can get Amazon.com users, Facebook users, Google users, all that stuff. And as you scroll down this page, basically, it will show you for each of these providers what you can get. For SAML, you can access these variables, etc. And it basically describes what it means, the variable value. So I will let you explore this in your own time, obviously, but I just want you to get educated to the fact that it is possible so that if you see the policy, then you will understand it very clearly. Finally, little exercise. I want you to have a look at the policies on S3 at this link. We won't do it together, but please have a look at these on your own, understand what they mean, see the advanced nature of them. Look at DynamoDB as well. There's some advanced policy on DynamoDB you can do. You need to be aware of those. And the exam may trick you about RDS. IAM policies, remember, don't help with in-database security because RDS is a proprietary technology, and so the user authentication and authorization has to happen from within the database. So if you see a weird IAM policies with some variables applied on RDS to do authorization within RDS, that's usually not the way it's done. Okay, so just to give you some idea, but this is more of a self-exercise. So click on these links, take the time to learn about these links and learn about these variables, just get educated. And hopefully your brain will be open to these new possibilities. All right, that's it from me. I will see you in the next lecture. So let's talk about CloudTrail. And CloudTrail is so important for the exam, but the questions are actually pretty easy. CloudTrail is used anytime you want to provide governance, compliance, and audit for your AWS account. Basically, it will track every API call made to your account. And so it could be from the console, it could be from a CLI, it could be from SDK, it could be from whatever. By the way, CloudTrail is enabled by default. So we'll get a history of all the API calls made within our AWS account. And as I said, it comes from all these various sources. And the really cool thing about it is that from there, we're able to say and see who did what and when, which is quite helpful, you gotta say. Now, all the CloudTrail can be put into CloudWatch logs, so we can get an information of all the logs, all the API calls that were made straight into CloudWatch logs and maybe query them from there. And if a resource is, for example, deleted in AWS, that is a very common exam questions, then the first place we need to look into is CloudTrail because we will be able to see who does a CloudTrail API call for a delete right away. Now, CloudTrail will show only the 90 days past of activity, so you need to basically store the data somewhere after that, could be CloudWatch logs or somewhere else. And the default will only show the create, modify, or delete events, so events that change things. But you are able to create CloudTrail trails. And these CloudTrail trails are more detailed. Basically, you can choose the kind of events you want to log, and then you can store this trail directly into S3 if you wanted to analyze it further. Maybe you want to use Amazon Athena on top of it to query these CloudTrail trails logs. Now, CloudTrails can be either region-specific or global, so you have these options. And when you store them into S3, automatically they will have SSE S3 encryption applied to them whenever it applies into S3, so it's quite neat. Then, if you want to protect, obviously, these trails for whatever reason, you would use IAM or bucket policies or whatever you want to protect them. So that's it for CloudTrail. Now, let's go have a play with it. So for CloudTrail, it's really easy. Let's go into the CloudTrail console. And CloudTrail, as I said, is activated by default. So you will get information around all the events that happen in your account by default. So if you see here, there's recent events. So this is all the things that happen in my code. And so when I was in my account, and so when I was dealing with DynamoDB, it logged this. When it was dealing with EC2 network interfaces, it logged it. So you can view all the events in there. And in there, you're able to basically filter by read-only, event name. You can specify some filter. You can specify a time range. So you're really able to just see a lot of things. For example, we can do events resource type, and then we'll do resource type equals DynamoDB. So let's just type in DynamoDB. It'll probably be quicker. Here we go, DynamoDB table, and it will give me all the events around DynamoDB. If we wanted to just do event name, and then we can just type in here something like delete cluster. Here we go, delete cluster. I can see there's a delete cluster event that was happening here for DynamoDB DAX. So you can really drill down into all the events down there within your CloudTrail. And if you wanted to have more than 90 days of past events, you could create a trail. And with creating trail, you can basically create event metrics, trigger alerts, run advanced queries with Athena, create workflows, etc., etc. So the way we do it is that we click on create trail. You can also do it from the dashboard here, or you can click on trails and then create trail. So perfect. And then you create a trail name, so we call it my trail, and you'll say, okay, it applies to all the regions. Let's do it for all read-write events. So I'll say all data events. So whether you want to have also the events coming from S3 and Lambda, if you wanted to. So you could tick here and get all the read-write events for S3 if you wanted to. And then finally, where you want your CloudTrail events to be stored. So I'll call it Stefan CloudTrail event, CloudTrail trails. Here we go. And it's going to create a new S3 bucket for me. You can specify a log prefix if you wanted to, and specify encryption parameters such as SSCKMS, log file validation, and if you want to have SNS notification anytime a log file is being delivered. For now, that's fine. I'll click on create, and bucket already exists, so I'll go trails2, create, and now my trail is being created. So now basically, anytime I will be doing some API calls within my AWS account, it will appear in this S3 bucket. So I'm going to do a few API calls and get back to you. Okay, so now I've just done a few events in my account. I've basically deleted and created DynamoDB tables, all that stuff. And so if I go to S3, it took about maybe 10 minutes. Basically, under my S3 bucket, under AWS logs, here's my account ID. And we got two buckets, two folders. The one that's interesting is CloudTrail. And then I'll go to US East 2. And then by date, so 2019, etc., I drill down. I found two files basically representing all my API calls in there, which I can download. And by downloading this file, it's basically a JSON document, what we'll see in a second. So I've just opened that JSON document, and now we can see that, for example, I did an AWS API call in this region, and it was a describe configuration recorder status, etc., etc. So you can just scroll down in your files and see what you did. For example, for KMS, I list the aliases, all that stuff. So all the API calls happening within your account will be in CloudTrail. If I type delete, maybe you'll have a delete event. No, it's not in this file. Anyway, you get the idea. Okay, lastly, we go to trails and we go to my trail, and I'm just going to stop it. So I can just stop logging, and that will make the previous file accessible, but it won't log any new events. Or you could go ahead and simply delete my trail altogether and click on delete, and the trail will go away. All right, that's it for CloudTrail. I hope you liked it. I will see you in the next lecture. VPC endpoints are really important to understand with the exam perspective because they enhance the security of your network within your VPC. Basically, anytime you have an AWS service, usually it's accessible on the public network. But sometimes, using VPC endpoints, you're able to connect to these AWS services on your private network instead of using the public network. So as a graph, because I'm sure I'll make everything clearer, here's your VPC, and for example, you have SQS. SQS is a public service. You can access it, for example, from your local computer, and so it's accessible on the World Wide Web. But say you wanted to access it from within an EC2 instance on a private subnet. So how do we do this? Well, one way would be to give internet access to that EC2 instance, but that would be a bit tricky because you need to create a public subnet, an internet gateway, all that stuff. Or you can just create a VPC endpoint, also called private link, which basically has a private connection directly into the SQS service. And then to connect to the SQS service, simple as that, your EC2 instance will connect directly into the VPC endpoint thanks to route tables. So that gives you an idea of the diagram of why VPC endpoints are super important and how they work. So they scale horizontally and they're redundant. You don't need to manage them. AWS does that for you. And they basically remove the need to create an internet gateway, a NAT gateway, NAT instance, or whatever to access any AWS services. You have two types of VPC endpoints. You have the gateway endpoints, and they're basically to provision a target, and they must be used in the route table. And that only works when you have S3 or DynamoDB. So remember this, VPC endpoint gateway are for S3 and DynamoDB. And then you have interfaces to provision ENI, so it's a private IP address as an entry point. And then most AWS services will have an interface VPC endpoint that's also called a private link. So that gives you an idea about VPC endpoints. Let's just see how we could set up one in the console. Okay, so let's open the VPC service in the console. And within the VPC service, I'm going to go to endpoints on the left-hand side. Here in the endpoints, I'm able to create an endpoint. And basically, you can either look for by services, or you can do the AWS Marketplace services if you wanted to. But we'll do AWS services in here. And for example, I'll do SQS like this. Let's do a search, which obviously does not work. Anyway, let's scroll down. And you have SQS right here. Com, Amazon, AWS, US is2 SQS. Excellent. As you can see, that's an interface. And here I can go to the bottom and basically create it. And at the end, say create endpoint. I won't go over the details of it. You just need to know the architectural implications of this. So SQS is an interface. And so if we look in this type on the right-hand side, the column type, only S3 is going to be a gateway. The interface is a bit clunky, I'm sorry. So the S3 is going to be a gateway. And then if you scroll up, the other gateway is going to be for DynamoDB, again, clunky interface, but DynamoDB. So DynamoDB and S3 are the only two gateway of type for the endpoints. All the rest, CloudFormation, CloudTrail, Config, EC2, etc., ECS, everything is an interface. So that's it. I just wanted to show you this. We won't go ahead and create an interface, but remember what it means at the high level and the VPC endpoints usage for security. And I will see you in the next lecture.